Here we have a consequence of the mean value theorem. If f is differentiable on AB and f prime of x equal to 0 for all x in AB, then f is a constant function on AB. We have two conditions here. The first one, f needs to be differentiable on this open interval. Second condition, f prime of x equal to 0 for all x between a and b. And the conclusion is f is a constant function. Let's prove this. We use the mean value theorem to show this one. So assume that f is not a constant function. So prove by contradiction. Assume that f is not a constant function. So this means that there must be 2 points, say alpha, beta, between A and B, so that f alpha is different from f beta. So this means that f alpha minus f beta is not 0. Now you see that f is continuous on alpha beta. F is continuous on the closed interval alpha beta. This is true because f is differentiable on AB. Alpha beta on AB. Differentiables must be continuous function. So f is continuous on alpha beta. And f is differentiable on alpha beta. This is because f is differentiable on AB, and therefore s must be differentiable on alpha beta. And therefore by mean value theorem, there must be the point C between alpha beta, so that f prime at C equal to f beta minus f alpha divided by beta minus alpha. This we use the mean value theorem here. Now we know that f alpha is different from f beta, so the numerator is non-zero. So this is different from 0. F prime of C is different from 0, which contradicts to the fact that f prime of x equal to 0 for all x between AB. C between alpha beta, so obviously C must be between AB. So this is not true because f prime of C is non-zero, which contradicts to the hypothesis. And therefore our assumptions is wrong. And therefore f is a constant function on AB. Now we will use this theorem to compute this one. Example, compute arcsin of 1/5 plus arc cosine of 1/5. So to do that, we consider the function f of x equal to arcsin of x plus arc cosine of x. And you know that f is continuous on the interval. Let me use the interval -1, 1. So f is differentiable on -1, 1. F is differentiable so you have this condition here. F is differentiable on AB, which our function satisfy. F prime of x. Let's compute that derivative. F prime of x is arcsin x plus r cosine x prime. Arcsin is prime, so remember s here. 1 over, s stands for square root and subtraction. 1 minus x squared. Arc cosine is minus arcsin prime. Arc cosine prime is 1 over minus 1 over square root 1 minus x squared. So this is 0. So f from x is 0 for all x between minus 1 and 1. So it satisfies the condition of this theorem. So the theorem says that f must be a constant function. Thus, f is a constant function on minus 1, 1. So f of x equal to the same number for all x between minus 1, 1. I can choose a value of x that I feel is easier to compute. Choose it to be f at 0. So instead of computing f at 1 over 5, I compute f at 0, which is arcsin at 0 plus arc cosine at 0. Here's our unit circle. Arcsin of 0. So arcsin of 0, we need to find what is it, equal to an angle theta. So theta must be sine axis is this axis. So by convention, theta must be between minus pi over 2 to pi over 2. So theta between minus pi over 2, pi over 2. So sine theta equal to 0. Theta between here, sine equals 0. So there's 1 point right here. So theta equal to 0. So arcsin 0 is 0. That's one thing we compute. Now let's compute the other thing. Arc cosine of 0. Arc cosine at 0. Cosine axis is here. So we know that arc cosine of 0 is an angle, say theta. Theta between 0 and pi. But we want arc cosine of 0 equal to theta. Cosine of theta is 0. So theta between 0 and pi, cosine 0. So that angle theta is pi over 2. So this one equal to 0 plus pi over 2, which is pi over 2. So f of 1/5, arcsin 1/5 plus arc cosine 1/5 equal to pi over 2. So by the theorems we took proof, we show that this one is pi over 2. And actually this is true for all x between minus 1 and so on. This one is always pi over 2.